Jai Hind to all. I am Updesh Kumar Jaishwa, working as an assistant professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I am going to deliver a lecture of subject object-oriented programming, and the topic is the polymorphism and its types. So you can say types of polymorphism in C++. Firstly, to understand the polymorphism and its type, we should know the concept of access control, access modifiers, access specifier in classes. There are different names having the same thing like access control, access modifier and access specifier in classes in case of C++. Access specifier in C++ class define the access control rules. For this purpose, C++ has introduced three keywords: public, private and protected. These access specifiers are used to set boundaries for availability of member of class to its data member or member function. Access specifier in the program are followed by a colon like this. We can use either one, two or all three specifier in the same class to set different boundaries for different class members. So I am going to discuss about the public access control or public access modifier. In case of public access modifier, class member declared under public will be available to everyone. The data member and member function declared public can be accessed by other classes too. Hence, there are chances that they might change them. So, the key points here that member must not be declared public. An example showing public access is given below. Class, the name of class is public access is used. In the definition of the class, I am using the keyword public, and after the public word I am using a colon. It represents the public access specifier, and in this case I have taken one variable x of type integer. Here I have written the semicolon. Then a member function with the name display is declared in this class. So here the public field having the data member and member function, and these both data member and member function are available outside the class. The private access modifier means that no one can access the class member declared private outside that class. If someone tries to access the private member, they will get a compile time error. By default, class variable and member function are private. It should be notable that in case of C++ programming language, class variable and member function both are private by default. An example showing private access is given below. Here I have taken a class, so I have used the keyword class, and the name of the class is private access is used, and in this class I have used the private access modifier, private access specifier, and there are one data member and one member function which are privately defined. Protected. Protected is the last access specifier, and it is similar to private. So it makes class member inaccessible outside the class, but they can be accessed by the subclass of that class. Subclass of that class can be used. If class A is inherited by the class B, then class B is the subclass of base class A. So class B can be inherited or can be used the protected data member and member function. An example showing protected class is given below. Here I have taken a class with the name protected access is used, and in case of protected field, I have taken one data member and member function, and they are of the protected type. So access control is protected. So only this class and derived class can access these data member and member function. Now, polymorphism. Polymorphism is derived from the Greek words poly and morphos. There are two words which are taken from the Greek words poly and morphos. Poly means many and morphos means form. So we can say polymorphism means the ability to take more than one form. I am going to give one real time example of polymorphism. Suppose if you are in a classroom, suppose you are a boy and you are present in a classroom, so you behave like a student in a classroom. When you are going for a market, then you will behave like a customer. When you are at the home, you are behave like a son of your parents. Here one person has different behavior. So concept of polymorphism exists in this real life example. Here a boy, if shopping mall, behave like a customer. If he is using the bus, then behave like a passenger. In the school, he is behave like the student, and at the home, he is behave like a son. Types of polymorphism in C++. It is a very important concept. There are two types of polymorphism: compile time polymorphism and runtime polymorphism. Compile time polymorphism is also known as the static polymorphism, and it occurs due to early binding. And runtime polymorphism is known as the dynamic polymorphism, and it occurs due to late binding. So in this diagram we can see types of polymorphism: compile time and second is the runtime. Compile time is also of two types. First is method overloading, second is operator overloading. In case of runtime polymorphism, the first one is virtual function and second is function overriding. I will discuss each and every one by one in the next slide. Compile time polymorphism. In C++ program, we can achieve compile time polymorphism by early binding in two ways, that is the method overloading and operator overloading. Now I am going to explain about the first type, that is the method overloading. Whenever same method name is existing multiple times, many times in the same class with different number of parameter or different order of parameter or different types of parameter is known as method overloading or function overloading or procedure overloading, because method, function, procedure are similar. So method overloading, function overloading or procedure overloading, we can use these terms. In the program given in the next slide, I am using there the sum function in a class, but it has the different signature or arguments. This is the example program of method overloading in C++. Here header file is included. I have taken a class with the name addition. In the public access control, public access modifier, I have taken a member function with the name sum, and there are two parameters a and b integer type are passed here. In the body of the sum function, sum method, I am showing the output as a plus b. Now in the same class addition, again I have written the sum method, but here three parameters a, b, c of integer types are. In earlier method two parameters, but in same name method having the name sum, there are three parameters now, and In the body of this sum, I am showing the result as a plus b plus c. Now, in main function, I have created an object with the name obj of the class addition. Now, this object is calling the sum function, sum method, but there are two parameters of integer type, that is the 10 and 20. What does it mean? It means this object is calling this sum function because there are two parameters of integer type, and in this sum function a and b, two parameters are integer type. So output will become a plus b, that means 30. But again I have written obj dot sum. Now I am passing three parameters 100, 200 and 300. So now this sum function is called, which has three parameters of the integer type. So result will be a plus b plus c. If I am passing 100, 200, 300, then these results will be sum up and output will come 600. This is the example of early binding occurs. Here early binding again occurs 2 times. Now operator overloading. Operator overloading is possible in C++. You can change the behavior of an operator like plus, minus, etc. to do different things. Operator overloading is sometimes referred to as the ad hoc polymorphism. It should be notable, that is the ad hoc type. So a single operator plus, when placed between two integer operators, then it will give the result of the sum up. But when it is placed between the two string, then both the string will be concatenated. Suppose I am using the plus in case of 10 and 20, then this operator will give the result 30. But I am using string a and b and I am using the same operator again, then in this case concatenation of the string will be occurred and result will be ab. So is single operator plus, when placed between two integer operands, add them, and when placed between two string operands, concatenate them. Consider two string s1 and s2. We can concatenate two string s1 and s2 by overloading plus operator as a string s is equal to s1 plus s2. I am going to give an example program for operator overloading. As we know, plus plus x increments the value of x by 1. Suppose x is equal to 100, I am writing plus plus x. What does it mean? 101. It is the general. But suppose I am using the concept of operator overloading, then this plus plus x will be increase the value by 100, not 1. So here same plus plus operator is used in the different way. If you want to overload this and increase the value by 100, I have written one program. I am going to show that program. Here header file iostream is included. I have taken a class with name test. So class test. In the private field, I have taken the count variable as integer type. In the public access modifier, I have written the test and count 250. Then I have used this bracket. What does it mean? We write operator before overloading such operators. Void operator plus plus. Now count is equal to count plus 100. I have taken the value of count is equal to 250 and new count will be 250 plus 100. Void display, see out cout, and in the main function I have created an object T of the class test and plus TT. Here operator overloading it occurs due to this method, and this method will be called, and the value of count, new count, will be 250 plus 100, and T dot display, in this output will be display. So 250 plus 100, 350 output will become. So this plus plus T is not increasing the value 1 here, it is increasing the value 100. This is the one of the example of operator overloading. Okay, polymorphism are two types. One that is occurred due to early binding, and function overloading and operator overloading are the example of these. And polymorphism which can be occurred by the late binding, function overloading and virtual function, I already told. So now runtime polymorphism. In C++ programming, we can achieve runtime polymorphism by using the concept of late binding, and it can be done by two different ways: function overriding and virtual function. Now I am going to discuss about the function overriding. Define any method in both base class and derived class with the same name, same parameter or signature. This concept is known as the function overloading or method overloading or procedure overloading. It should be notable that in case of function overloading, I am using the one class, but in case of function overriding, two classes will be used. First is the base class and derived class. It is a case when a function is declared with the same name in both the parent class and child class. It means function having the same name in the base class as well as in the derived class. To decide upon which function has to be called, the program will only known at the runtime, so it is known as the late binding. Example of method overriding in C++. Here I have taken a class with the name base. In the public field I have taken the member function so, and in the body of this function the output will be displayed as the base class. Now another class with the name derived is declared here, and which is the derived from the class base. So here base is the main class, parent class, and derived is the child class. Now in the body of this derived class, in the public field, again show method is here. In base class also show method, in derived class also show method, but in the base class show method, the body contains the output as a base class, but here the body of this derived class in which the method show is defined, in the show method body derived classes will be shown. In the main function, an object b, small b, is created of type base. What does it mean? It means I have created an object b of the class base. Another object d is created from the derived class, of the derived class. Now b dot show and d dot show. B dot show, b is the object of base class, and it will call the show function of this base class. So output will come base class. But when d is the object of derived class, and d dot show means we are passing a message that object d is calling the method show of the derived class. So here derived class will be printed. So it will be the output, and it is the one of the example of late binding. at the runtime it will be decide which source function is called by which object. Now virtual function in C++. A virtual function is a member function of a class that is declared within a base class and redefined in the derived class. Again here base class and derived class are used. When we want to use same function name in both the base class and derived class, then the function in base class declared as a virtual by using the virtual keyword, and again it can be redefined in the derived class without using the virtual keyword. Here I have given the syntax of virtual function. This is the function name, return time after that function, and before that virtual keyword is used in the base class, and the body of that virtual function is written. Now I am going to give one example program in C++ where virtual function is implemented. I have taken a class with name A. In the class I have taken the function show, return type is void, and before that I have used the keyword virtual. So this show method is a virtual function which is defined in the base class. Now I have taken another class B which is derived from the class A but publicly. Public keyword is used, and colon word is for the showing, that is the derived class. Now again in this derived class or subclass show method is written. In base class show method, in derived class show method. But here output is the hello derived class and function is redefined here. So this show method and this show method have different bodies but having the same name. This show method is exist in the base class and this show method is exist in the derived class. Here this show method is again redefined. We can write more words, more equations here. Now main function. In main function AOBG is the object of A class and BOBG is the object of B class are created. Now a pointer BPTR is taken of the class A. BPTR is equal to asterisk AOBJ. BPTR pointed show call base class function. Now if BPTR is equal to asterisk address of BOBJ, then this BPTR so it will call derived class function. So firstly here due to this line base class function is derived, so here as output hello base class will be printed. Now here derived class function is called, so output will be hello derived class and function is redefined here. So this was the concept of virtual function. So from these discussion we have learned one more thing, that is the message passing. An object oriented program consists of a set of objects that communicate with each other. The process of programming in an object oriented language involves the following basic step: creating classes that have data member and member function, creating objects from class definitions. Now stabilizing communication among the objects. Message passing, that is called as the communication in C++, is the exchange of information between two or more objects via a logical entity known as the message. Objects communicate with one another by sending and receiving information much the same way the people pass message to one another. A message for an object is a request for execution of a procedure and therefore will invoke a function in the receiving object that generates the desired result. This is shown in this picture. Message passing in C++ involve specifying the name of the object. Here, the name of the object is employee. The name of the function is salary, and passing the parameter as a name. So this is the object. This is the method name salary, and information as a parameter. So these whole is one of the example of the message in C++. So what you learned today? Types of polymorphism, compile time and runtime. Compile time is of two types, method overloading and operator overloading, and runtime is also two types, virtual function and function overriding. I explain all these things with suitable example programs in this lecture. So I have concluded my lecture today. I use these references to make this lecture. I use 5 textbooks, 3 websites and 3 research papers. Thank you and Jai Hind to all of you.